Okay, greetings. I'm going to knock my mug off this here in a minute, but what I wanted to do was to make sure it's do a review of energy before we get into chapter 19 here, which is electric potential and electric potential differences and electrical potential energy and those kinds of things. Now, there's a difference between electrical potential, which you know as voltage. Electric potential, this battery is 1.5 volts, I think. Pretty sure. Can't seem to find what the voltage is, but I think it is 1.5 volts. It's a AA battery. Yeah, there it is, 1.5 volts. Okay, so 1.5 volts. In other words, the amount of negative charge down here on this end, on the cathode end, and the amount of positive charge, or well, it's actually just less negative. Okay, so then there's a way to calculate that. But the amount of charge over here and the amount of charge over here is 1.5 difference. Okay, and that creates a voltage, and that creates a potential, and it's a potential to do work. All right, so with that in mind, you are so used to gravitational potential. Now, if I take this battery, now let's look at mechanical. This is not electrical. This is mechanical work, but we can use electricity to do mechanical work. In fact, that's what a battery does. A battery takes chemical energy and turns it into electrical energy, which we then use to make mechanical energy to get stuff to move. All right. So here's the idea. So let's just look at mechanical energy, and let me get rid of the battery, otherwise that'd be confusing. Let's grab another fun physics thing, the yo-yo that I have on my desk. All right, so if I take this yo-yo and I raise it up here like this, and I raise my yo-yo up here like this, I have increased its gravitational potential energy. And then when I drop it, okay, it loses gravitational potential energy and gains kinetic energy. All right? In other words, it wants to go down. When an object with mass moves to where the gravitational field, which works the same as an electrical field, when the gravitational field grabs this thing instantly, well, actually the gravitational field, I'll be honest, it travels at the speed of light. Okay, the gravitational field grabs it to our eyes practically instantly. Boom, and it pulls it down, so it loses gravitational potential energy and gains kinetic energy. What you are not used to. So let's grab another object. Let's grab another fun physics thing is silly putty. All right, so let's grab, and let's say this is a proton. All right, and then up above the ceiling, let's say this is a proton. So what kind of charge does it have? Positive charge, or let's just say it's positive 3.0 times 10 to the negative 6 coulombs. All right, I've got it down here. Up here, I have a bunch of negative charge. Okay, and that negative charge has an electric field going into it, right? So down below here, this bottom tier right here, right along here. If you can see my entire screen, I don't know if you can see, or if you're just seeing this part. So along this line right here is a bunch of positive charge. So that positive charge down below, the proton doesn't want to hang around there, so it goes up. And in fact, it's got a force. It feels the electric field, which creates a force on it because it's got a charge. Q times E equals a force. That's what we learned in the first two lessons. Equals a force. Now it's going to go a distance. Force times distance is work. It actually lost. You Nimrod. Yeah, it actually lost potential energy by going up. It lost its its electric potential energy by going up and attaching itself to the negative plate. Okay, because that's where it wants to go. Now, it would take work. If it's a proton, it would take work for me to pull it down here. I'd have to use something outside of it and get it to, finally, get it to stick down here with the other protons. But now it's free to go again, so it slams back up here again. And it's got a change in energy. So that's the thing I wanted to make sure that you understood, was that when we change, when we have a potential difference, which is a voltage, it's almost just like a change in height for gravitational potential energy. Remember where we had GH? And I'll show you all this here in a minute, and we'll go through it, because I think the slides are good on this, but I wanted to make sure we understood it before we even got started. Okay, I think the slides are good, but I'm going to do this review of energy. So remember, you got MGH was potential energy, and how the H's changed, because G never changes. All right, that's something else we got to get used to, is that the gravitational energy that we always use, we're always here on the Earth, so that really never changed. But the gravity does change. You get on, you get further and further away from the Earth as you get, the less and less gravitational pull you have. Same with the electric field. The further away you get from the positive charges, and if there's no negative charges out there, the further away you get from the positive charges, the weaker the electric field gets. Okay? And if I stick a negative charge out there, way out there in deep dark space, somewhere way out in deep dark space, I have a negative charge, and let's say this is now a negative charge, all right, and it's way out in deep dark space, and all of a sudden it feels this electric field, a positive an electric field going in the opposite direction of it, and so it's going to come towards those. It's going to come towards those positive charges, because that was a negative charge. It will lose electric potential energy, and there's an algebraic way you can do this so that you'll never screw it up. It'll lose potential energy, but it will gain, it'll get going faster and faster, and it will gain kinetic energy, and we can actually calculate its velocity. Just based on, remember when we dropped something and we said 1/2 mv squared equals mgh? We do the same thing. We set 1/2 mv squared equals q times delta v, which is the change in potential. Volts is the same as potential, which is the same as electric potential, but they are not electric potential energy. Electric potential energy is charge times voltage. All right, there you go. That's chapter 19 in a nutshell. Knock yourself out, do the homework. Ha, kidding. We're going to get on it now, but I just wanted to do that intro. All right, out here.